All forgiveness versus permission, right? I don't know if that's good advice. Don't take my advice.
That's advice for parents if they're strict.
Yeah, don't take my advice. All right, so we are recording. It is Friday. This is day 2 of 5.02 lesson. We're going to graph equations on the polar coordinate system. This is going to be something new, exciting, and make sure you have a graph paper out. Maybe Desmos open, I think, is a good idea. Let's take a look. All right, being recorded. It's a pretty short lesson, by the way. All right, so graphing polar functions. We went over this yesterday about the r comma theta, the radius and basically the radius and the angle. All right, so looking when we graph, so if you're just given theta equals pi over 4, so let's think about this. Looking at this graph, let's stop and think. If I said theta is pi over 4, how would we graph that? Just think for a moment, like, what would that look like to you? If you were only given the angle is pi over 4, how would you graph that? Any ideas in chat? See, Antonio said, draw a line on pi over 4. Line on pi over 4, a line. So I'm getting a lot of like lines, and you are correct. So, and the reason why it's a line is because, well, the angle is pi over 4, but the radius is open. There's no radius restriction. So if you think about it, we could do an infinite number of points on the angle pi over 4, and you would get a straight line. So let me get my line tool here. Let's take a look. So pi over 4. Hopefully this works. Pi over 4. You would get a line. So I'm going to just put like a line next to that to show that's what it is. So yeah, you would get a line. The angle is pi over 4, and the radius is anything. So if you put an infinite number of radiuses, right? And if you put enough of them, it makes a straight line. Pretty neat, right? Pretty neat. Any questions on that? By the way, we're going over six types of polar graphs. So this is one of the 6. So we got 5 more. No questions. All right. Okay, so next we have the r value equals 3. So kind of stop and think. Well, I'm giving you the radius, just the radius. And if you're given just the radius, what would that look like on your graph? So Emily says a circle, question mark. We got Kayla says a circle also. Dianica says a circle. The third circle, what does that mean? The third circle. Oh, okay, I see what you mean. You meant like the third tick mark out. Okay, that makes sense. Third tick mark. So a circle. People who answered, you are correct. It is a circle, and if you think about it, I'm giving you just the radius, r being 3, radius of 3. I don't give you the angle restriction, so that means you can draw a point at every degree imaginable as long as your r value is 3. That sort of makes sense. So if you think about it, you draw an infinite number of points on r equals 3 going all around, and well, if you draw enough points, it'll be a circle. All right, so we're gonna draw a circle. I'll do it in green. Okay. Hopefully it's not a filled in circle. One, two. I think I made 1, 2, 3. There we go. Look at that beautiful circle. That's almost perfect. All right, so I'm just gonna Put a little, yeah, so it makes a circle. So there's the second type of polar graph that we're going to learn about today. That's the second out of 6. So we're just chugging along. Let's keep going. Oh, by the way, there will be a quiz at the end of this lesson. 6 questions. So make sure you're snipping these pages or taking good notes, because on the quiz, I won't be able to go back to previous pages to show you the different types. So fair warning, right? Fair warning. All right, so general graphs. All right, and we just talked about this. So for an equation, when you have theta equals k, the graph is a line. And the slope is just going to be what that k value is, like pi over 4. And we talked about that last slide. And then when you have r equals k, the graph is a circle, radius being the r value, what it equals to. We talked about that already. And again, k is constant. So okay, so graphing a polar function. In this case, I'm giving you the equation r equals 2 theta, and I'm telling you the restriction is your angle theta must be greater than 0. Okay. And just like when you learned, whether it's freshman year or in probably, I don't know, when you learn to graph functions, 5th grade, 6th grade? I don't remember. It's been so long. We'll say 5th grade. You make a t-chart. Well, it's the same thing here. You're going to make a t-chart. And so I made, looks like, so if you notice, you would think, hey, theta is probably your dependent variable. Oh, sorry, independent variable, which it is actually. And then r would be your dependent. Okay, I set it up right. So remember, this is radians. So I decided to choose values that, well, in radian form, using the unit circle. So just going up in increments of pi over 4. So pi over 4, pi over 2, pi, and so forth. And you can use any values for your points. Just kind of use them. You don't want to go from like 0 to pi to 2 pi. Then you're just like doing a half a rotation. That won't give you enough points. So you want to probably, I think going up pi over 4 is probably good. And that way you're going from basically quadrant 1 to quadrant 2 to 3 to 4. And then you just basically keep going a circle. I think that's probably sufficient. If you want to go up by like increments of pi over 6, you're just going to have a lot more. So pi over 6, another pi over 6, pi over 6, pi over 6. So you can make it however you want. I think this is probably good enough. So we just type these values into your calculator. So and round to 2 decimal places. All right. When you plug in pi over 4, chat, what do you get? What is the answer for the r value? Uh, 0.785. Okay. Good. Oh, wait, I got 1.57.
It's because we didn't times it times 2. We times 2, it is 1.57. So yeah.
Okay. Yeah, okay, so we're good. All right, good. Because I make type mistakes all the time. I think I do math in the dark. Maybe that's the problem. All right. When you type in pi over 2, what do you get? So remember, the equation is r equals 2 theta. So you're plugging into theta. 3.14. Okay. Yeah, and so you get the idea. You just keep plugging those in, right? And we get this. So let's do this. I want you guys to plot these for me. So let's do this. Who wants to do the first one? Plot the point. All right, Antonio, the first one. Who wants to do number 2, the second one? Julia, number 2. Who wants number 3? Caitlin, go for it. Number 4.
Should we just ignore the fact that the graph says 5, 10, 15, and 20?
Yeah, you're just gonna do your best. Well, no, it does. So look, it goes from like 1, 3, 6, 9,
Oh, okay,
12,
okay.
15. Yeah, it goes up pretty big. So that's why
Okay,
my
okay,
graph
gotcha.
does it. Okay.
I
Yeah.
was confused. Okay, I can do the next one.
All right, Emily, number 4. Number 5, anybody? Oh, I'm sorry, guys. I did this yesterday. I forgot to turn off the cameras and I forgot to turn on drawing the whiteboard. I blame Antonio for not reminding me because it's his job. Starting right now.
I apologize.
And also being retroactive. So
I don't get paid enough for this.
All right, number 5. Anybody? Number 5, anybody? No, number 5? Okay, well then we'll just start over. Antonio, you'll do number 5, and then whoever I said was doing 2 will do number 6. Number 3 will do number 7, and then number 4 will do 8. All right, ready to go. Let's do this. So I think this point is off some. Remember, this is 5. This is a radius of 5, radius at 10. So,
Oh, I thought you said ignore those.
no. You need to respect them because the values go up. So just, I think Antonio, yeah, I understand what you did. Yeah,
Okay.
I understand what you did. So yeah, you just use your best guess for the points, right? And you can make your point bigger. You can make it huge, like Antonio did, so we can see it.
Quick question.
Yep.
So I'm assuming for the 3 pi one, we take it into degrees and then use that to kind of roughly estimate. I'm assuming
No,
it's at 180 right now.
no. Look, so all of the angles they're already in radians.
Well, yes, but the 3 pi doesn't fall on the graph though. A full
So
circle is only 2 pi, so I have
right.
to somehow.
Okay, so let's big brain this. So if one rotation is,
So I'm thinking it's gonna be here.
I know, you're right. It's going to be here because we have one rotation is 2 pi, and then one more pi would be a half a rotation. So we're gonna be over here somewhere. So you're right. Yeah. So you just have to big brain it.
Okay. Oh, I got you. Click no. Okay. I got you. Oh wait, someone already did it. Okay. Thank you.
Yeah, that looks good. We're missing I think a point over here. Do we have a coordinate? What is that? 3 pi over? Do we have 3 pi over 2? Yeah, who's doing 3 pi over 2? Yeah, we're missing 3 pi over 2. We're missing this value.
Yeah, sorry, I screwed up 1 sec.
Antonio, she deleted your point over here. Oh, there it is. Yeah, so
That
we're
was my
missing.
point.
No, I
Okay.
I actually did it. I just hit undo accidentally and undid my point.
Antonio, graph the point on 3 pi over 2. Okay, so
Yeah.
that wasn't me, by the way. I don't know who it was.
that's okay. And then we're missing.
Thank you, Emily.
Then we're missing this point as well. So we're missing the point on 2 pi. And then I think we're missing this point as well. Yeah, we're missing these 2 points. All right, so we got that one done, and then we need just one more. So somebody plot that. So one more point. One more point. Who's gonna do it?
I can do it real quick. So it's $1.50 for the degrees, and then at 15 something. So, why did I draw the circles again? I'm leaving that one, taking that one out. 15 point something. So somewhere roughly around here. I should be right. Possibly. Probably not. But we're okay.
Oh wait, no, we got this one right. No, we got this point. I'm sorry. Yeah, I think we got this point. I think that's one right here, right? That's this one.
Isn't that pi over 2 though?
Uh,
Because 5 pi over 2 is 450 degrees. Oh, wait, that's right.
Yeah.
I've done math wrong. My bad.
yeah, no. Okay, we're good. We're good. All right. So once we have the points, and really, you want to do these points by yourself because it's kind of hard to see the first point, second point, third point. But once you do graph them by yourself, what happens is we are going to draw this line, and hopefully I don't mess this up. So what happens is it basically looks like this. Look at that. So that's what the graph actually ends up being when you plot points, right? It does a circular. Yeah. So on this next page, I actually have it perfect. There we go. And that it keeps going, right? We stopped on this graph here, and let me show you something. So in Desmos, by the way, we're probably going to use Desmos this unit because I found it easier to use than GeoGebra for a lot of things that I'm going to show you. And I would advise doing the same thing. So let me share my screen with all of you because I want to show you something pretty awesome, in my opinion. Let's see. Let's do, where's my Firefox? There we go. Firefox, share. All right, Antonio, voice chat, do you see my screen?
Yes, we can.
All right, you see my big mouse moving around?
Yep.
All right, so in Desmos, I have these three things here. This is the formula R equals 2 theta, and I'm making my theta value from 0 to A, and then my A value, I can change this A value, and I just made it 10 pi, so I did, what is that, 5 rotations I'm doing? 10 pi, so I just did 5 rotations, but you can make this anything you want. You know, I would at least do probably 3 or 4 rotations for sure, so you can see it. But this way, I can kind of drag this value. You can see it kind of paints the path, right? It's kind of neat. And then what I can do is I can actually set this to really anything, and then I can click it, and then it shows me the coordinate. So it kind of makes doing that T-chart pretty easy if you think about it. And I can also make my A value like a radian, like let's say pi over 6, right? And I hit enter. And well, I now have my value here. But we don't, let's see, oops, messed up my slider. Fix that. Just keep undoing until I fix it. All right, there we go. I got my slider back. All right. But then in Desmos, I'm able to define my A value to do 5 rotations, leaving step blank. And here I'm telling it to repeat forever. And when I hit the play button, and I changed my speed because if it was regular, it would go super fast and we'll be able to see the path. But and then I wrote this other line here, and we haven't learned this yet. So, you know, you don't have to understand this formula as of yet because I haven't gone over it yet. But that dot you see, that big point is this right here being drawn. The line that it's going to draw, the path, is from this first equation. So I had to create an equation for the line and or the arc, that is, and an equation for the actual points. And this is defined as A cosine A and 2A times sine A. But I'll go over this later. But anyway, so I just hit play, and we can see that as A increases, so my t-chart, the path is going to keep rotating, right? And I'm going to do, what did I say, 5 rotations? So I got to keep zooming out. But yeah, you can kind of see what's going on in this graph. It's kind of neat. And then it starts over, and this does it again. And you can always pause it, and you can click on the point, and it'll show you, where it's at. I can even drag this this value kind of around to see what's going on. So I'm going to paste this. Let me just paste it.
To do a certain number of rotations, like you said 5. How do you set it to do that? I missed that.
Let me just paste it in chat.
Okay.
That'll be easier. So you don't have to reinvent the wheel. There you go. So you can click that, and that's what I was just looking at here.
Okay, cool. Thank you.
Mm-hmm. All right. Let me go back to what we were doing. All right. So going on. Let's go on. So yeah, there's your crash course on actual graphing those coordinates. Not too bad. Just kind of time consuming. All right. So our third type out of the 6 polar graphs would be a rose. All right. Now we're going to have 2 types. We're going to have, and by the way, the rose is defined as, well, the equation is r equals a sine of n theta, or r equals a cosine n theta. It doesn't really matter which one. You're going to create a rose. But what does matter is the a value, your amplitude, right? If it was a regular trig function, sine, cosine, or the other ones. It's the amplitude. So a represents, I'm kind of jumping around here. A determines how long your petals are. So you can kind of see, this is actually really blurry. When a is 3, your petal length is 3 units. So they're all a radius of 3. Our value is 3. Oh, that's this value here. So when this is a 5, well, the length of each petal is 5 units. Okay, so that's super easy. There's no like special math you have to do to pull those out. So that's nice. The number of petals is defined by these 2 bullet points, and this is important. So whether it's sine or cosine, if your n value is even, the number of petals you're going to have would be 2 times that. So if this happens to be like a 4 theta, I actually don't have an even example. You can go into Desmos and try it out. So if that was 4 theta, well, that means that you would have a total of 8 petals. And then if it's odd, like these 2 examples, they're odd. This tells us that you're going to have just n petals. So this right here is 3 theta. So that tells you, well, it's odd. So that's 3 petals. Well, this is 5 theta. So this has 5 petals. And that's it. Those are roses. Questions on a rose? All right. So that's 3 out of the 6.
Why the heck is it called a rose when it looks absolutely nothing like a rose? Shouldn't it just be called like flower or something?
No. That's what they're called. Somebody math long ago says, "Oh, this category, this would be considered a rose." Polar
We don't
graph.
make the rules.
We don't make the rules. We follow. Yeah, and what Antonio says. All right, so let's look at these. We have 4 examples. Let me give you. Let's do 2 minutes for these 4 problems. Super easy. If you're paying attention and writing notes down or snipping notes. All right, 2 minutes. Ready to go. Nope, it's not. Yes, Julia, you
They're
can do number
working
one.
now?
We're done. It's working now.
Okay, so I'm confused on how you get the number of petals because I know it said something about like if it's even it's pi whatever. But how does that play into getting like 3 or like 5 petals or whatever? Is it just the number that's in front of the theta?
Well, if it's
'Cause
odd.
that's
So up here,
oh,
let's
it's
see.
2n. Okay, yeah.
Yeah,
I
see.
no, I see it. I misread the n as pi. I saw it
Okay.
as pi, so I'm like, if and it's
Okay.
even the rose has 2 pi petals. I was super confused. I'm like, that's like not possible.
I understand. I get you. So to make your screen bigger, if it's like really small and if you're using a small screen, you can minimize the cameras, so drop them down so you can't see them. There's really no point to seeing me or anybody when we're in class, in my opinion. That is. So you can drop that down, and then there's a full screen button, which is up on the top here. It looks like a box, and I think you can also press F11. Is it F11 or is it F12? I forget. Or is it F10? Let me try F11. Actually, I'm using a Mac, so it's not the same. I think it's F11. Let me see what mine says. Full screen. Actually, I can't see what the hotkey is, but I'm pretty sure it's F11. But anyway, or maybe it's like Control F11. But anyway, there's a button for it.
It is F11.
Okay, it's F11. All right. All right. So Julia, number 1, Antonio, number 2. Who wants to do 3 and 4? All right, Emily, number 3, number 4. Let's go, people. People who don't usually volunteer. Let's go. Be a part of the class. Let's do this. Let's do a quick poll. Choose choice C if you are here. Yeah. So if you're here, hit C. All right. Who's here? Who's here? Come on. Let's go. We got people who haven't responded yet. Answer faster. We got one person that's not here. It's a sad day. I see you. I know who you are. All right. And everyone chose the correct choice. So nice job. All right. All right. Number 4. Who wants to do it? All right. Someone's doing it. Good. I'll take it. All right. Everyone confirm that these are all correct. I'm not going to go over them, but are they correct? Everyone agrees? If you disagree, I'll go over them. Number 4 is off. So we have 6. So yeah, so that's your oh, looks like it's backwards, right? Yeah, so these should be, remember, this is length of petals is this value here. So you just had them flip-flopped, it looks like. So you gotta take good notes and have them in front of you, right? Don't give up on math. Oh my gosh. Yeah, she's grouchy this morning. She's under the covers right now. In the class, I'll pull her out and show you. All right. So, yep. Nope. Did it again. Number of petals. So I'm going to go on number of petals. This is going to be 5 and length is 6. So yeah, all looks good. You know, worst case scenario, you just go to Desmos and you just like type it in and hit enter, and you can graph it out and see what it looks like, right? All right. So now here's the other 3. So we have line, circle, and roses. Those are 3. And now here's the other 3. We have cardioids, limicons, and lemniscates. So cardioids, limicons, and lemniscates. I could be pronouncing them wrong. I probably should have checked before class, but I'm going to go with what I'm saying. Because math is art. That's why. Math is beauty. There's math, especially when involving like trig like this, and plants especially. I watched some documentary showing like math in nature and things growing and creating these rotations and growth. Fractals, yes, fractals. That's yep. Nice. You maybe you saw the same thing. Yeah. So yeah, there's definitely beauty in math for sure. All right, cardioids. So I have cardioids. This is an example of a cardioid. And it's a polar graph with the equation r equals a plus or minus a sine theta, or r equals a plus or minus a cosine theta. Doesn't matter which one. A must be greater than 0, though. That's important. Can't have negative. And that creates kind of this motion here, right? So if you're into audio, music, recording, whether it's like podcasting or you record vocals, mics, so like dynamic mics, or, well, I don't know. I'm not using a dynamic mic. Mine's a regular mic, USB mic, a condenser mic it's called. But I have, they're called polar patterns. So the one that I'm using right now is actually the cardioid polar pattern, which means it's recording from the front, not the sides or the back. So there's different polar patterns for microphones and how they pick up sound. So kind of neat. And that's if you're into audio and that sort of thing. So pretty neat stuff. So there's math in that. There you go. All right. And that looks like this. So that is number 4. The 4th type is cardioids, identified by this equation. Limicons, so another polar graph. That equation, though, is, well, r equals a plus or minus b times sine theta, or r equals a plus or minus b times cosine theta. Now, for this to be a limicon, this is, well, it has to be, a and b. Obviously, these must be different values. Because if they were the same, it would be considered a cardioid, because then they would match A and A. So A and B, they got to be different values. Also, your B value must be less than your A value, but your B value must be greater than 0. So this is important. This is the restriction to be considered a limicon. And that looks like this. This and this. These are limicons. Now, if you notice, this one kind of actually looks like a cardioid. So sometimes graphs, when you look at them, you really can't say, oh, it looks like this, so it must be a cardioid. Well, it could actually be a limicon, and you'd actually have to see the equation to make that determination. So don't let the picture of a graph confuse you to picking the wrong answer. The equation will give it all away. All right, the one that has the loop. So this limicon that has this loop in the middle here, Um, this is done when your A value is smaller than your B value. So that is that case. You're going to have that inner loop when the A value is smaller. All right, so that's lemicons. And the final type of graph is lemniscates. So this equation is super easy to spot. Like this makes a figure 8. You're going to have some, you may have different ones. I think you actually can have a lot more loops. You can do crazy designs depending on what this value is here in the parentheses. So that equation is in the form of r squared equals a squared times sine of 2 theta, or r squared equals a squared times cosine of 2 theta. So these are really easy to spot, and if you see a graph, it's pretty easy to say with certainty that's what it is. Unless it looks like a rose, then you probably should. So I guess lemniscates could be confusing with roses, possibly, if you had two graphs side by side. So maybe be careful on these as well. But these are the other 3 types. So make sure you snip this page or you wrote this stuff down, because we are going to have a quiz on the next page. Lovely. Lovely, she says. All right, so let's do the quiz. Here we go. Does everyone have this snipped? Because we're probably gonna not be able to see this page once I show the quiz. All right, here we go. Quiz time. Quiz time. Here we go. All right, so I'm going to give you, let's say we'll do 5 minutes for this quiz. I think that's enough. And if I can see your responses, I'll be able to tell if you are done or not. So if everyone's done and within the 5 minutes, obviously I'll end the timer, but give you about 5 minutes to do these. So good luck and ready to go.
Dr. J, it says done. Please wait for the others to finish for all of our screen.
It's not working. Why isn't it working? Hang on. Let me see if
Maybe because you had it on for an infinite amount of hours.
maybe I'm just bad. Let's try this. Is it working now?
Yeah, it's working.
Can you guys see?
Can't take it.
Can you guys see my answer? Well, I'm sorry. What, Antonio?
I can't take it because I'm moderator. So
Well, not anymore. You're not. There you go. But also make sure that when you're done, make sure you write down all your answers on a piece of paper because we will go through these to confirm, to make sure my key's right, and to make sure all of you understand. All right. Anybody need more time in chat or on voice? Let me know. All right. What number are you currently on? Just give me an idea. So number 4, number 5. All right. Yeah, I gotta. I think we have a few more minutes to spare. So I give you 5 minutes already. Let's do. What time is it right now? All right, let's do another 2.5 minutes.
Will we be able to see like our results afterwards?
Yeah, we'll go over these. Yeah, so make sure you write them down on a piece of paper. I don't know. Once we're done, I don't know if it's going to show you what you put when I hit end. So write them down so you know what you chose. And you can write them down as just A, B, C, D, E, or F because I'll actually have those choices on this next slide. So you can just write down A, B, C, D, E, or F of what you put. Save you time. So you shouldn't be using Desmos to determine what type of graph it is. I said this earlier. You can't trust graphs always. So the characteristics of the equations is what you need to look at to determine what it is. And yes, you can't graph one of them in Desmos or GeoGebra. It's a limitation of the actual website. So yeah, you should be using the equation, not how it looks. Because if you do it how it looks, you could miss some of these easily. Yeah, it's all about those numbers. It's a numbers game. Yeah, and I did say this. I did say this. So I think people who kind of walked away or tabbed out doing your Insta, Twitter, or whatever it's called, or sleeping, maybe you didn't do so well, or maybe you didn't take good enough notes. So you need to be active in class, and that's taking notes, that's working out examples, that's typing stuff in. So you're part of the experience, and if you're part of it, you're going to learn better. Trust me, I know this. All right, time's up. So go ahead and make sure you at least click something for your answers, because I'm going to hit end quiz in 5 seconds. 4, 3, 2, 1, 0. All right, end quiz. Here we go. All right. So let's see. 16 people responded. So everyone was playing this game. Average score was a 79%. Not terrible. I blame that score for people who kind of checked out, whether beginning, middle, or end, because there's some that nobody should have missed. All right. Let's look at the ones that nobody should have missed first. And so number 3, I think number 3, nobody should have missed that one. R equals 4. So radius is 4. That is a circle. So somebody put a line. I don't know how many people. I'm guessing just one person. Doesn't show me the number. Unfortunate. Come on, Neuro. Update your stuff. I need data. All right. Also, number 4. Number 4 is a very unique problem, right? Because it has squared in it. R squared. That is a giveaway. R squared equals 4 cosine 2 theta. And maybe because you didn't see 2 squares, but isn't 4 2 squared? So isn't it R squared equals 2 squared times cosine 2 theta? Isn't that right? Ooh, math. 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 Yep. So, number 4, nobody should have missed that one. Lemniscates, those are really obvious to spot, like super easy. I had some people, one person looks like did a line. I don't know why you picked a line for number 4. That's definitely not a line. Someone picked a rose, not a rose, and someone picked a cardioid, definitely not a cardioid. There's a square in there, R squared. I also could have wrote number 4 as R equals a square root of the entire thing, and that also would have satisfied that. Just looks different because I radicaled both sides. All right, and then nobody should have probably missed number 5. Theta equals pi. That is a line. There is no radius restriction, so it's definitely not a circle. One person put circle, so maybe that same person just mixed up circle and line. I could understand that. All right. Number 6, R equals 9 cosine 6 theta. So that's definitely a rose. Yep. There's no like plus or minus term in there to be like one of the other ones. So I think roses are pretty easy to spot too, equation wise. One person put lemnicons, but let me go back to the actual playlist. Here we go. So let's go over these answers real quick. Time's running out. So number 1, that is a lemnicon. So A and B are different. So it's not a cardioid. That is a lemnicon. Number 2, A and B are the same. So it's definitely a cardioid. See, 4 and 4, those are the same. So it's definitely a cardioid. R equals 4. So radius is 4.
Really quick, can you put the link into the chat for the people who have to go?
Make sure you look at that too, because there's actually a correction on my last slide that's in your learning module. Let's see. Let me put the link so all you can have this. People are here. There you go. All right, so r equals 4, radius is 4. That's a circle. R squared equals that stuff. That is definitely a lemniscate. Those are super easy to spot. Theta equals pi. That is definitely a line. And r equals 9 cosine 6 theta. There's no plus or minus term, and there's no squaring or square rooting, so that's definitely not a lemniscate. That is definitely a rose. So there's characteristics that you just have to just practice these. You know, they're very different. Picture-wise, graphical-wise, some of them might look the same, so don't trust your graph. Don't need to graph them. All right, final thoughts. So again, there's 6 types: line, circle, rows, cardioids, limicons, and lemniscates. Seeing the graph, like I said this multiple times now, that you know, don't trust the graph. The best way is look at the equation. It's a giveaway. And then corrections. So at least a month ago, and I highly doubt they fixed it, page 7 of the Learn module, graph equations on the polar coordinate system. Problem number 3 on page 7. Problems 3 and 4. Okay, should both have a 2 in front of the sign. So there should be a 2 should be in front. So if you notice that, there you go. There's the correction for the Learn module. I don't know if they fixed it or not. Lemon biscuit? I don't know about that. All right, everyone. And that's it. So thanks for coming, everyone. And as always, I hope you learned something. I will see you all on Monday. Take care.